Alright guys, here are the 2-8 notes, graphing inequalities in two variables. If you can graph, you can do these no problem. So our essential question, what does a dash boundary represent on the graph of an inequality? Okay, graphing inequalities, very simple. Create the graph of y is less than 2x minus 1. Okay, again, the only thing different with inequalities is this sign here. So less than 2x minus 1. First decision is decide what type of line to be used. First off, you use a solid line if it's less than or equal to and greater than or equal to. And you used a dashed line for strictly less than, we call it, or strictly greater than. So that's strictly less or greater. Okay? And that's about the first idea. So decide what line type to use. As you can tell, we are going to use a dashed line. And from there, it's just graphing the same. So if we recall, -1 is our y-intercept. And we have a rise of 2 over 1. So up 2 over 1, up 2 over 1. And we can do the same idea in the opposite direction, connecting them with what we decided upon is a dashed line. Now, 9 out of 10 times, that's where students stop. But a dashed line and solid line is not all we need to do. We also need to shade. Okay, we need to decide where to shade. There's a few methods on how to do this. The easiest thing I like to call is the test point method. And it means that you choose a test point to decide where to shade. Now, so you plug in x, y, any test point not on the graph. Not on the line. Typically, 0, 0, unless your graph goes through it, is the easiest one to test out. So I'm going to test out the point 0, 0. Okay, right at the origin, as long as your graph doesn't go through it. If it's true, the statement, that's where the treasure lies. That's where you want to shade it. If it's false, I'm going to choose green for true. If it's false, we're going to shade on the other side of the line. So on the other side of the line. What do I mean by true and false? Well, if we substitute 0, 0 into y is less than 2x minus 1, so we have 0 is less than 2 times 0 minus 1 is 0 less than, that's just going to be 0, -1. Is that true? Is 0 less than -1? No. That means we want to shade everywhere else. Okay. So a dashed line and shading is also required. And you can use your graphing calculator to check. There's a program that will do that. And online, if you don't have graphing calculator, there's something known as Desmos. That's only at home only though. I cannot let you use that on the test. So another example here, and you should hopefully have a good grasp of this. Or a decent one, okay? So, create the graph of, oh no, an absolute value. Okay, that's what we just looked at, but it's okay. We have h, and we have k. Okay, and we have the slope out front. Solid or dashed line, first decision, is going to be solid. Why? Because of the greater than or equal to. Graph these as you did last unit, okay? The vertex is at HK, and you need to be careful. It's a positive 1. That means it'll be at -1, comma 2. Okay? Our slope is just 1. So from our vertex, -1 up 2, we have a positive slope in either direction. Solid line, so we connect with such with the solid line. And check for symmetry, looks pretty good, and we're going to decide on, again, we can choose the point 0, just for the heck of it, let's pick 0, 1, 0, 1 actually. 0, 1, and again, you can choose any point not on the graph, and we'll try it out. So is 1 greater than or equal to the absolute value of 0 plus 1 plus 2? Here's where all of the order of operations stuff comes into hand. So is 3 less than or equal to 1? That is false, meaning we want to shade everywhere that the point is not. So the point is on the outside of the graph, so we want to shade on the inside. Notice that again. The point is outside. Since it was false, we shaded inside. Okay? That is really the main idea. The only additional thing you need to worry about is shading. Again, most of the time mistakes that are made is that students only choose to use dashed lines and they forget to shade. Okay? Forget to shade. Here are two for you to practice. This one here, you can use either the XY method with 0, 0, since we're in standard form, or you can always solve for Y, and this will give you good practice with the absolute values. Recall what it's going to be, and then H and K, of course, is your vertex. Alright, 8 minutes for that one. Shouldn't take you too long, and good luck, and we'll see you in class.